In part A, you do not have any options. All the 20 questions, that is 15 MCQs and 5 fill in the blank questions are compulsory. All of them you have to attend. So according to Markovnikov rule, we have studied that when an hydrogen halide is added to an alkene, the negative part of the addendum, that is negative part of HX, the central metal atom in BeH2, that is beryllium, it is not having 8 electrons in its outermost shell, but still it is stable. Hello everyone, this is Ambili Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So today I am back with the model question paper of 2023-24 exam, which is given by the Karnataka board. So in today's session, we are going to see the model question paper. This will be discussed in 2 sessions. Okay. So the first session, we'll be starting with the first few sections of it. So as you know, there are 5 sections, that is section A, section B, section C, section D and section E. Right. So in each of these sections, what all type of questions are included, all of that we'll be discussing in this session, and each question in detail we are going to solve it. Okay, so this is the model question paper which is given by the Karnataka board for first PUC, which is for the exam 2023-24. Right, so as you know, it is a 3-hour 15 minutes examination. Okay, so the maximum marks for the theory exam is 70 marks. Right, 70 marks will be the maximum marks for the theory exam, and the rest 30 marks you will be getting from your practical examination. Right, so the theory marks, that is this question paper that we are going to discuss here, is for 70 marks. Right, now there are few instructions that we have to read through. Right, so the question paper has 5 parts and have a total of 52 questions, and all parts are compulsory to attend. As I told you, Part A, Part B, Part C, Part D and Part E will be there. So Part E is exclusively for numericals. So you won't be finding any numericals in any other part, that is from Part A to Part D. Part E, that is the last part, is only for the numericals. Okay. So Part A carries 20 marks and each question carries 1 marks. Okay, so the first part is Part A, which is carrying 20 marks and each question is for 1 mark, that is 1 mark questions. So total you will be getting 20 marks from Part A. You have MCQ questions as well as fill in the blank type of questions from Part A. So 2 types of questions will be there. First part will be, that is in Part A itself you will have 2 parts, that is MCQ as well as fill in the blanks. Right, now moving on to Part B, it carries 10 marks and each question will be 2 marks, and Part B will be having 2 mark questions. So a total of 10 marks you will be getting from Part B. Now Part C carries 18 marks and each question will have 3 marks. Each question will be having 3 marks. Total of 18 marks we can get from Part C. Now Part D also carries 10 marks. Each question carries 5 marks. So Part D contains 5 marks question, and the last part which I told you, which is exclusively for numericals, which carries 12 marks and each question carries 3 marks. So in each of this part, how many questions are there, we are going to discuss in the next slide. Okay, so the next point, in Part A questions, first attempted answer will be considered for awarding marks. So whichever answer you have written first, as it is MCQ, whichever answer you have written first, that will be considered as the first answer. Right, now balanced chemical equations and draw neat labeled diagrams and graphs wherever necessary. So wherever in chemistry, wherever graph is necessary, you have to draw that. Wherever equations or diagrams are necessary, you have to draw that. Right, now direct answers to the numerical problems without detailed steps and specific unit for final answer will not carry any marks. So just writing the answers is of no use. You have to do the steps. How did you obtain that answer? The steps for the numerical problems are very, very important. And use log tables in simple calculator. Of course, you already know scientific calculator is not allowed for your examination. Simple calculator you can use, and log table will be provided to you. Right, now let's move on with the question paper. So as discussed, so first part is Part A, which is having 20 questions in total, which is all compulsory to attend. There is no internal choices in Part A. All the 20 questions are compulsory to attend. So the first 15 questions will carry 1 marks and first 15 questions will be MCQ questions. Okay. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So these 15 questions, first 15 questions will be MCQ questions, which will be 1 mark question. In part A itself, you have the second part, that is Roman number 2 in part A itself will be fill in the blanks by choosing the appropriate word. So a set of words will be given to you and the fill in the blank options will be there. So the appropriate word you have to fill into these options. So you have 5 questions here. Okay, that is 5 into 1, you will get 5 marks here. So 15 MCQ questions and 5 fill in the blank questions from part A, which will give you a total of 20 marks. I hope it is clear. So this is about part A. Now moving to part B. As discussed, part B contains 2 mark questions, right? So answer any 5 of the following. So in part B, you have a total of 9 questions from which any 5 you can choose. Okay, as you can see, 21 to 29. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 questions will be there from part B and you have choice here. Okay, out of this 9 questions, only 5 you have to attend. So each question will carry 2 marks, hence 5 into 2, you will get 10 marks from part B. Okay, I hope it is clear. Each question carries 2 marks. Only 5 you have to attend from part B. Now moving on to part C, you have again 2 parts, that is Roman letter 4 and 5. Okay, so in the first section of part C, you have to answer any 3 of the following and each question will carry 3 marks. So you have 1, 2, 3, 4, 5 questions here in the first part of part C. Out of this 5 questions, you have to only attend 3 questions. And for these 3 questions, you will get 3 marks. That is, each question will carry 3 marks. So total of 9 marks from the first section of part C. Right. Now the second section, that is 5th section, again answer any 3 of the following. Each question will carry 3 marks. So from 35 to 40, you have 6 questions, out of which again you have to answer any 3 of the following. Again you have a choice here. And for this 3, each question will carry 3 marks. So again 9 marks from the second part of part C. Now moving on to the next part, that is part D, and the next session is part D, in which you have to answer any 2 which will carry 5 marks. So each question will carry 5 marks. So 5 marks for each question, 2 you have to attend. So you will get a 10 marks from part D. So you have 1, 2, 3, 4 options here. So from these 4 questions, you have to attend 2 questions. Each question carry 5 marks. So a total of 10 marks from part D. Now the last section or last part is part E, which is numericals, right? So from numericals also answer any 4 of the following. Each question will carry 3 marks. So 4 into 3, you will get 12 marks from numericals. So you have 1, 2, 3, 4, 5, 6, 7, 8 questions. From this 8 questions, you have to write only any 4 questions. So for each question 3 marks, so a total of 12 marks. So this is how the marks are distributed in each sections. I hope it is clear. So in part A, you do not have any options. All the 20 questions, that is 15 MCQs and 5 fill in the blank questions are compulsory. All of them you have to attend. So from part B, you have choices. Okay, part B 2 marks, part C 3 marks, part D 5 marks and part E 3 marks. So in that, from part B to part D, you are having choices. Okay, so now let's begin with the part A of the question paper. So we are going to see the part A of the question paper. We are going to discuss it. So the first question, that is the first part of part A, select the correct option from the given choices. So as I told you, the first 15 questions are MCQ questions. So let's discuss the first one. The number of significant figures in 0.523. Okay, so number of significant figures in 0.523. Okay, so in this particular value given, the first non-zero digit is 5, right? So 5, 2, 3. All these are non-zero digits which are significant, right? So of course these 3 are significant. What about this 0? This 0 is not significant, right? Okay, because all zeros are non-significant until certain conditions, okay, and this 0 is coming before the decimal point, so it is not significant. So only which are the 3 numbers which are significant? 5, 2 and 3, which are 3 non-zero digits. Okay, so the answer will be 3. Right, okay. So this is about significant figures. Now the next question, molarity is defined as the number of moles of solute present in 1 liter of solution, 1 kilogram of solution, 1 liter of solvent, 1 kilogram of solvent. Okay, so you have to be very careful while choosing the answer also. Solution is given as well as solvent is given. So have to be very careful in that way also. So what is molarity? Molarity is number of moles of solute present in 1 liter of the solution, right? 1 liter of the solution. So option A is your answer. So what is the equation that we have studied? Molarity is number of moles of solute present in 1 liter of the solution. Okay, another equation, number of moles, how we can expand it? Number of moles is given mass by molar mass, right? Given mass of the solute by molar mass of the solute divided by volume means that will come in the numerator, right? So volume. Okay, so if volume is given in milliliters, we divide it by 1000. So this is the equation that we have studied for molarity. Okay, so molarity is number of moles of solute present in 1 liter of solution. Then what is molality? Molality is number of moles of solute present in 1 kilogram of solvent, right? Not solution, solvent. Okay, moving on to the third question. Rutherford's alpha ray scattering experiment is related to the size of nucleus, atom, electron or neutrons. So the option A is the correct answer. Why? Because Rutherford's alpha ray scattering experiment, we have studied the various observations, we have studied the conclusions also for Rutherford's alpha ray scattering experiment, and in the conclusion we were able to conclude that the nucleus is present in the center of the atom in a very small area, and most of the mass of the atom is residing in this nucleus itself. So it tells about the size of the nucleus, right? Not the atom, electron or neutrons. It tells about or gives an idea about the size of the nucleus. Moving on to the next question. Mendeleev's periodic table is based on atomic weight, number of neutrons, atomic number or number of electrons. So of course Mendeleev's periodic table is based on atomic weight, right? It is based on atomic weight, right? And what or which periodic table is based on atomic number? Which one it is? It is, yes, the modern periodic table. So it is very important to remember that modern periodic table is based on atomic number. Okay, and Mendeleev's periodic table is based on atomic weight. So which is your answer? Option A is your answer. Moving on to the next question. In HCF4 molecule, the number of lone pairs and shared pair of electrons respectively are. So in HCF4 molecule, we have to find out how many number of lone pairs are there, how many number of bond pairs are there. So xenon, as you know, it is a noble gas. How many electrons are there? How many valence electrons are there? 8 electrons are there. And it is forming bonds with 4 fluorine molecules. That means 1, 2, 3 and 4. Okay, so a total of 8 electrons xenon is having in its valence shell. So already 4 electrons are taking part in bond formation. As you can see, this 1 electron, 2, 3 and 4. These are taking part in bond formation. Now how many are left? 4 more are left, right? So 1, 2, 3, 4. So as you can see from here, the Lewis dot structure, you can see there are 4 bond pairs, right? 1, 2, 3 and 4. 4 bond pairs and 2 lone pairs are present. Okay, so as you can see here, first they have asked, and be careful while choosing the answer also, they've asked you first the number of lone pairs. So how many lone pairs are there? This is 1 lone pair, this is another lone pair. So 2 lone pairs and 4 bond pairs are present. So this is the answer, 2 bond pairs and 4 lone pairs. Next question, which of the following is true for ionic compounds? So it conduct electricity in solid state, soluble in polar solvents, have directional bonds and are non-electrolytes in molten state. So it is regarding ionic compounds. Ionic compounds, for example, we can take sodium chloride. Sodium chloride is an example of ionic compound. So in presence of or in solution phase, what will happen? It will dissociate into Na plus and Cl minus. That is, ionic compounds in its solution phase, what happens? It will dissociate into its constituent ions, and those ions will help in conducting electricity. So this option is the option which is correct. They are non-electrolytes in molten state. Okay, they are non-electrolyte in molten or solid state because they can't conduct electricity. Once it dissociate, it will conduct electricity. So that is the right option. Now moving on to the next one. The second law of thermodynamics introduced the concept of enthalpy, work, entropy, internal energy. Okay, so second law of thermodynamics gives an idea about entropy. So what was entropy? It is the measure of degree of randomness or disorderness of a system. So that was given by the second law of thermodynamics. Moving on to the next question. The difference between the heat of reaction at constant pressure and heat of reaction at constant volume is greater than RT when delta Ng is equal to 1, delta Ng is greater than 1, delta Ng is less than 1, delta Ng is not equal to 1. So which of this option? So first let us see the difference between heat of reaction at constant pressure. What is heat of reaction at constant pressure? That is QP. Heat of reaction is at constant pressure is what? Yes, it is enthalpy, right? That is delta H is heat of reaction at constant pressure. Now heat of reaction at constant volume. Heat of reaction at constant volume is what? Yes, it is change in internal energy. So the difference between these two is greater than RT when which of this condition is followed. So which is the equation which relates between delta H, delta U and RT? So it is delta H is equal to delta U plus P delta V. We have already studied this equation. This is the equation which relates enthalpy of reaction and the internal energy. So as from the ideal gas equation, we know that PV is equal to nRT. So in place of P delta V, we can substitute N delta R delta T, right? So we write delta H is equal to delta U plus R delta T. NR delta T. That is, this N stands for delta Ng. Right. So we can write it as delta H is equal to delta U plus delta Ng RT. Right. So this is the equation we require. So what does the question say? The difference between heat of reaction at constant pressure, that is delta H, and heat of reaction at constant volume. So we need the difference. So I take this term to this side. So we get delta H minus delta U is equal to delta Ng RT. Okay. So this is the equation we require. So for what value of delta Ng, we'll get this value which will be greater than RT, that will be delta Ng which is greater than 1. So this equation is the equation that we require. So when delta Ng is greater than 1, then this difference will be greater than RT. So I hope it is clear. Moving on to the next question. Lewis acids are proton donors, electron pair acceptors, electron pair donors, or proton acceptors. So we have studied about acid base theory, right? And in that, according to Lewis theory of acids and bases, Lewis acids are substances which can accept electrons and Lewis bases are substances which can donate electrons, right? So the question asks, Lewis acids are, yes, the answer will be electron pair acceptors. Okay, acids will accept electrons, base will donate electrons, right? So electron pair acceptors are called as Lewis acids, right? Moving on to the next question. During reduction, oxidation number. So this is an easy question. During oxidation, oxidation number increases. During reduction, oxidation number decreases, right? So the options are increases, decreases, do not change, depends on the reaction. So of course during a reaction, if reduction is taking place, of course the oxidation number will decrease. Okay, so the correct answer is decreases. Next question. The property catenation is more marked in the case of silicon, carbon, tin, copper. Of course, the answer is carbon, right? The property of catenation is shown highest by carbon. Okay, carbon is having 4 valency, right? So it is the one which is showing the highest property of catenation. Now the next one, methoxymethane and ethyl alcohol are position isomers, chain isomers, functional isomers, metamers. So what is methoxymethane? Methoxymethane is CH3OCH3. So this is methoxymethane. And what is ethyl alcohol? Ethyl ethyl alcohol is CH3, CH2OH. Okay, CH3CH2OH. So I've just expanded it and written it can be Ca2H5OH also, which is the condensed formula. So CH3CH2OH and CH3OCH3, methoxymethane and ethyl alcohol. They are which type of isomers? Is it position isomer? No. Is it chain isomer? No. Is there any change in the chain? No. Is it functional isomer? Yes, it is a functional isomer. Why it is a functional isomer? In this case, as you can see, there is this hydrogen, when it combines with the CH2, it forms CH3, and when the oxygen comes to the middle, it forms an ether. And this is an example of an alcohol. So, if the positions of this oxygen atom is changing, what is happening? You are getting two different functional groups, right? So, this is an example of ether and this is an alcohol. So, you are getting two different functional groups. So, it is an example of a functional isomer. So, I hope it is clear. Moving on to the next one. According to Markovnikov's rule, when hydrogen halides added to an unsymmetrical alkene, the hydrogen of HX attached to the carbon at the end of the molecule, the carbon in the middle of the molecule, carbon with least number of hydrogen atoms, carbon with the maximum number of hydrogen atoms. So, it is very, very important to read the question carefully. So, what does the question say? According to Markovnikov rule, when hydrogen halide is added, HX is added to an alkene. Okay, HX is added to an alkene. The hydrogen of HX get attached where? That is the question. So, HX is the hydrogen halide. If we are adding it to an alkane, where does this hydrogen atom go? That is the question. So, according to Markovnikov rule, we have studied that when an hydrogen halide is added to an alkene, the negative part of the addendum, that is negative part of HX, which is the negative part? This is the negative part, that is the halogen is the negative part. Halogen will attach to the carbon atom having lesser number of hydrogen atom. This we have already studied according to Markovnikov rule. But the question asks you in HX, where does the H will attach? Okay, in HX the hydrogen will attach to which carbon atom? If halogen is attaching to the carbon having lesser number of hydrogen atom, of course hydrogen will attach to the carbon atom having maximum number of hydrogen atoms, right? Okay, so which will be the answer then? Carbon with maximum number of hydrogen atom. So just don't see by Markovnikov's rule and go and choose the option C. Okay, C is right for the halogen atom. Okay, the negative part will go and attach the carbon with less number of hydrogen atom. Then the positive part, which is the positive part? Hydrogen will be the positive part. That will attach to the carbon having more number of hydrogen atoms. I hope it is clear. Moving on to the next question. Which of the following hydrocarbon damage DNA and cause cancer in the human body? So, all of these. So, as you can see, 1,2-benzanthracene, 1,2-benzpyrene, and 3-methyl chloranthrene. So, all of these are examples of compounds showing carcinogenicity, right? Now, moving on to the next part of part A, that is fill in the blanks. Fill in the blanks by choosing the appropriate word from those given in the brackets. So, few words will be given in the bracket and 5, as you can see, from question number 16 to 20, 5 questions will be given, that is fill in the blank questions. So, from the words which are given, you have to choose the appropriate word and fill in the blanks. So, let's see the first question. The outer shell of the most stable atom contains. So, the options aromatization 0 increases 8 electrons, CH2 and CH3. So, of course, from this itself you can see, from the question itself you can say the outer shell of the most stable atom contains. The only option that goes well with that is 8 electrons, right? It will contain 8 electrons. This is called as octet rule. The stability, the atoms will attain its stability by filling 8 electrons in its outermost shell, right? Second question, the standard enthalpy of formation of element is taken as dash by convention. So, it is taken as 0, right? It is taken as 0. So, standard enthalpy of formation of an element, standard enthalpy of formation of any element is taken as 0 by convention. Okay, next question, when the pH of a solution decreases, its hydrogen ion concentration increases. So, the next question, when the pH of a solution decreases, its hydrogen ion concentration is dash. So, what happens to it? From again go to the words which is given to you. Aromatization 0. 0 is already taken. Then you have increases CH2, CH3. So from this itself you can tell the only option that goes well with it is increases. Now why does it increase? What is the equation relates pH and hydrogen ion concentration? It is pH is equal to minus log concentration of H plus. Okay, so from this relation itself you can say when the pH of solution will decrease, concentration of H plus will increase. Okay, yes. Now moving on to the next question. In a homologous series of aliphatic hydrocarbons, the successive members differ from each other in a molecular formula by a dash group. So here you have a confusion. CH2 and CH3 is given. CH2 is given, CH3 is given. So which is the right option? CH2 is the right option, right? So this is called as a homologous series, right? So each member of this homologous series will refer by a CH2 group. So for example, let us take alcoholic functional group. So the first member is methanol, CH3OH. The second member is ethanol, which is C2H5OH. So as you can see, the difference between these two, this is a homologous series. The difference between these two is by a CH2 group. This is CH3, this is C2H5. They differ by a CH2 group, right? Okay. Moving on to the next one. Normal hexane on heating to 773 Kelvin under 10 to 20 atm pressure in the presence of oxides of vanadium, molybdenum forms benzene. This process is called, of course, the only option here is aromatization, right? It is called as aromatization. Okay, so the formation of benzene, it is called as aromatization. So this will carry 5 marks. So this is part A, 15 MCQ questions and 5 fill in the blank questions will give you 20 marks. Okay, so all these 20 questions are compulsory. Now moving on to part B. Okay, part B, as we have discussed, 9 questions will be there, out of which you have to answer any 5. Okay, so the first question, define entropy. What happens to the entropy when liquid changes into vapor? So as you can see, entropy is the measure of degree of randomness of a system. So how much a system is random or in disorder, that is called as entropy, right? So it is represented by the symbol S and the equation is Q by delta T, right? So this is entropy, that is the degree of randomness of a system or disorderness of a system is called as entropy. The symbol is S, right? Now the second part, what happens? So this part, define entropy, for that you will get 1 mark. Right, so this is 2 marks questions, part B. Right, now what happens to the entropy when liquid changes into vapor phase? So when a substance changes from its liquid state to vapor state, what happens to the entropy is the question. So it is a process in which a phase transformation occurs from liquid to vapor phase during evaporation. So this process is called as evaporation, right? So during evaporation, as liquid state changes to vapor phase, the randomness between the particles increases, right? So as you know, in solids the particle will be tightly packed. In liquid, little more space will be there. When from liquid it gets converted into gaseous phase, it will be having more space. So the randomness, of course, it will increase. The space between the particle increases means the randomness will increase. When the randomness increases, what will happen to the entropy? Of course, entropy will also increase, right? Due to which the entropy of the system also increases. So if a substance changes from its liquid phase to vapor phase, what happens? Randomness increases, hence entropy increases. Moving on to the next question, what is heterogeneous equilibrium? Give an example. Okay, so we have studied 2 types of equilibrium, homogeneous equilibrium and heterogeneous equilibrium, and you have to give an example. When the state of equilibrium in a state has components in more than one phase, it is termed as heterogeneous equilibrium. That means in that equilibrium, all the reactants and products, all of them should be present in the same phase. That means either if all of them are in gaseous phase, all of them are in solid phase, or all of them are in liquid phase, then we call it as a homogeneous equilibrium, right? The question asks you what is heterogeneous equilibrium. Heterogeneous means, yes, at least one will be in some other phase. So one example also, they have asked you, give an example that will carry 1 marks. This definition will carry 1 mark. So total of 2 marks. So calcium carbonate, which is in solid phase, it will dissociate into calcium oxide and carbon dioxide. So as you can see here, all the reactants and products are not in the same phase. These both are in solid phase, but carbon dioxide is in the gaseous phase. So this is an example of a heterogeneous equilibrium. Now for example, nitrogen and hydrogen combines to form ammonia. This is an example of a homogeneous equilibrium. Why? Because all of them are in gaseous phase. So I hope you understood the difference between homogeneous and heterogeneous equilibrium. Right. Now moving on to the next question. What are isoelectronic species? Select isoelectronic pair among the following. So Na plus, Cl minus, F minus, Li plus. These are the species which are given to you. First part of the question is, what are isoelectronic species? So what are isoelectronic species? They are elements or ions. They are elements or ions that have the same number of electrons. So they are atoms or ions which are having same number of electrons. They are called as isoelectronic species. So from the name itself you can say iso means same, electron means number of electrons. The number of electrons will be same. Okay. Now although isoelectronic species have the same number of electrons, they are different in their physical and chemical properties. Of course they are different atoms and different ions, right? Their physical and chemical properties will be different. Only the number of electrons will be same. So now 4 pairs are given here: Na plus, Cl minus, F minus and Li plus. So out of these 4 species which is given to you, you have to find out which 2 are the isoelectronic ones. Okay. So let's calculate the number of electrons in each one of them. So sodium atomic number is 11. Okay, in the ground state. Now it is Na plus, that means 1 electron is lost. So the total number of electrons here is 10 electrons. Moving to the next one, chlorine. The atomic number is 17, right? 17. So total number of electrons is 17, to which 1 more electron is added. This minus sign stands for 1 more electron. So it is plus 1, that is a total of 18 electrons. Now going to fluorine, atomic number is 9, that is total number of electrons is 9, to which 1 more electron is added because of the F minus. So 9 plus 1, it is 10 electrons. And the last one is lithium, that is atomic number is 3, from which 1 electron is lost. So 3 minus 1, it is 2 electrons. So from here itself you can see which is the isoelectronic pair. It is Na plus and F minus. So Na plus and F minus are the isoelectronic pairs. So this is how you have to calculate. In the ground state you have to check how many electrons are there, and based on the charge, that is if it is plus, reduce 1 electron, if it is minus, add 1 electron. Okay. So this is isoelectronic species. Moving on to the next question, give any 2 limitations of octet rule. Okay, so what is octet rule? Yes, that is the atoms will try to obtain 8 electrons in its outermost shell to obtain stability. So this is called as octet rule. Okay, so there are limitations, any 2 limitations you have to write. So I have mentioned all the 6 here. So you can write any 2 out of it. Okay, so the first one is it could not explain the stability of compounds containing less than 8 electrons around the central metal atom. Okay, so the central metal atom, if it is having less than 8 electrons, still it is stable. Okay, for example, BeH2, beryllium and hydrogen. So in this case, as you can see, hydrogen, helium, lithium, beryllium. So for beryllium, as you know, the number of valence electrons are 2. So 2 electrons here and 2 electrons here. So it will form a single bond. But still, as you can see here, hydrogen's duplet is completed. This hydrogen's duplet is also satisfied. But beryllium, it is having only 4 electrons in its outermost shell now. So is it supposed to be stable? No. But still it is stable because it does not actually follow octet rule. So this is an exception here. So it could not explain the stability of compounds containing less than 8 electrons. See, LiCl, BeH2, BCl3, all these are examples of compounds which are stable even though they do not follow octet rule. See, as you can see here, the central metal atom in BeH2, that is beryllium, it is not having 8 electrons in its outermost shell, but still it is stable. Moving on to the next one, it could not explain the stability of molecules containing odd number of electrons like NO and NO2. The central metal atom here in nitrogen oxide and nitrogen dioxide, nitrogen is having 5 electrons in its outermost shell, which is an odd number, right? So such species are also stable, which could not be explained by the octet rule. It could not explain the stability of molecules containing more than 8 electrons in the central metal atom, that is expanded octet. This is called as expanded octet, and PF5, SH6, H2SO4, IF7, all of these are examples of central metal atom having expanded octet. For example, P SF6 let's take. Okay, sulfur is the central metal atom, surrounding you have 6 fluorine atoms. So, okay, so as you can see here, the sulfur's number of valence electrons is 6. Okay, and surrounding you have 6 fluorine atoms. Each fluorine atom's octet is completed, that is 8 electrons will be present. But to the sulfur, if we calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, a total of 12 electrons will be present here. So that means instead of 8, it is having 12, right? So it is called as an expanded octet. But still SF6 is a stable molecule, right? It could not explain about that. Octet rule is based upon the chemical inertness of noble gas, but some noble gases like xenon and krypton form compounds with fluorine and oxygen. So as discussed, xenon, that is the noble gases, they are already having 8 electrons in its outermost shell. They are supposed to be stable, right? Hence they are already stable. They are not supposed to form any other compounds with any other elements, right? But still xenon and krypton, which are part of noble gases, they still form various compounds with fluorine and oxygen. Now this theory does not account for the shape of the molecules. It does not give an idea about shape of molecules. Also, it couldn't explain the stability of the molecules. Okay, so out of these, any 2 limitations you can write. Moving on to the next one, define hydrogen bond. Name a compound having intramolecular hydrogen bond. So 1 mark for defining hydrogen bond. So what is hydrogen bond? Electrostatic force of attraction that exists between hydrogen atom of one molecule and an electronegative atom of same or other molecule. Okay, whether it is existing between the same molecule or different molecule, based on that you have 2 different types, that is intramolecular and intermolecular hydrogen bonding. So what is hydrogen bond? For example, if HF is a molecule, yes, because of the electronegativity difference here, what happens? Fluorine will have a partial negative charge because it is more electronegative. Hydrogen will have a partial positive charge. Right, okay, and this hydrogen can form a hydrogen bond with the same molecule, that is a higher electronegative element which is present in the same molecule, or with a electronegative element, higher electronegative element which is present in another molecule. Okay, so based on that you have 2 types, intermolecular and intramolecular hydrogen bonding. So here the question have asked you, name a compound having intramolecular hydrogen bonding. So what is intramolecular hydrogen bonding? Hydrogen bonding is present within the molecule. Okay, so an example here is orthonitrophenol. Now what is orthonitrophenol? You have a benzene ring which having OH. So this is called as phenol, and in ortho position you have NO2. Right. So as you can see here, the oxygen is here, which is more electronegative than hydrogen. So this hydrogen and oxygen in NO2 will form a hydrogen bond. So this is present within the same molecule. This whole compound, you can see this is one molecule, right? So within the hydrogen of this compound itself and within the oxygen which is present in this compound itself, there is a hydrogen bond present. That is why it is called intramolecular hydrogen bond. Clear? Moving on to the next one, helium is monoatomic. Explain on the basis of molecular orbital theory. So this contains 2 marks. Helium is monoatomic. Why it is helium is monoatomic? You have to explain using MOT. So let's see here, the electronic configuration of helium atom is 1s2. Helium atom. Helium atom means only 2 electrons will be there. So it is 1s2. Okay. So each helium atom contains 2 electrons. Therefore, in helium molecule, there would be 4 electrons, right? Okay. In helium atom, 2 electrons. So 2 helium atoms makes 1 molecule. That is He2. So how many electrons will be there? 4 electrons in total. That is sigma 1s2 and sigma star 1s2 according to MOT. Right. These electrons will be accommodated in sigma 1s2 and sigma star 1s2 molecular orbitals, leading to electronic configuration. Now, helium molecules electronic configuration will be sigma 1s2 and sigma star 1s2. Right. So, this is bonding molecular orbital. This is anti-bonding molecular orbital. So, where you can see star, that will be the anti-bonding molecular orbital. So, there are a total of 4 electrons, 2 in BMO, 2 in ABMO. Okay. So, now we are calculating the bond order of He2 helium. So, what is the equation to calculate bond order? Bond order is equal to half of NB minus Na. Now, what is NB? Number of bonding molecular orbital electrons. How many electrons are there in BMO? There are 2 electrons, right? So half into 2 minus number of electrons in ABMO, that is anti-bonding molecular orbital. So how many are there? Again 2. So 2 minus 2, it is 0. So 0 divided by anything will be 0 itself, right? So the answer is 0. So the bond order of He2 is 0. Helium molecule is therefore unstable and does not exist. Okay. So I hope it is clear for you. So helium molecule does not exist. So it explains that helium is monoatomic. That means helium will exist as He only, monoatomic only. It can't exist as helium molecule. Clear? Because the bond order is 0. Bond order is 0 means, what is bond order? It is the number of bonds which is present. So bond order is 0 means, of course, the helium molecule is not existing. Hence, it will be only existing as helium atom, which is monoatomic. Clear? Moving on to the next question. Using the stock notation, represent the following compound: HAuCl4 and Fe2CO3. So let's take the first one, HAuCl4. So what you have to calculate using stock notation, represent the following. So how do you represent using stock notation? For that, first you have to calculate the oxidation number, right? Okay. So for the gold, Au, we do not know the oxidation number, so I take it as X. So chlorine, it belongs to halogen. So for each chlorine, you will have -1 oxidation number. And for hydrogen, it is +1, right? So +1, and for gold, it is plus X. Right, and for each chlorine atom it is -1. So there are how many? 4 chlorine atoms. So it is +4 into -1. Is there any charge? No. So it is equal to 0. So 1 plus x minus 4 will be equal to 0. So x minus 3 will be equal to 0. X will be equal to +3. So we calculated the oxidation number of gold, which we have to represent in stock notation. So if we have to represent in stock notation means we have to represent it in Roman numbers, right? So as you can see, HAu will write, after writing the symbol of the metal, you have to represent in Roman numerals whatever is the oxidation number. So it was 3, so we will write 3 here, then Cl4. Right, moving on to the next one, Fe2O3. So the first step is to calculate the oxidation number. For iron, we don't know, so we take it as X. How many atoms of iron are there? 2 are there. So 2X. Right, plus. Now for each oxygen, -2 is there. How many atoms are there? 3. 3 into -2 will be equal to 0. 2x minus 6 will be equal to 0. 2x will be equal to 6. X will be equal to +3. Again, it is +3. So Fe2O3. So this is how you have to write the stock notation. So 2 are given. So each will carry 1 mark. So the next question is for the compound CH triple bond C, CH double bond CH, CH3. First part is write the bond line formula for the above compound. Okay. And the second question is mention whether the compound is saturated or unsaturated. So as you can see, 1, 2, 3, 4, 5. 5 carbon atoms are there. So 1, 2, 3, 4, 5. So 5 carbon atoms you have to draw like this, right? And in the first junction you have CH triple bond C. So you have CH here, okay? So which you don't have to represent it. You just have to write the bond line formula. So no need to write the carbon or hydrogen here. So there is a triple bond between the first carbon atom and the second carbon atom, which you mentioned using these triple bonds, right? Then you have CH, okay, which is the C and the C. And then you have again a double bond which is represented like this, which is a double bond, and at the end you have CH3, right? So this is how you draw the bond line formula. And the next part is mention whether the compound is saturated or unsaturated. So of course, if there is a double or triple bond, the compound will be unsaturated. So like this you will get 2 marks. Now moving on to the next one, write geometrical isomers for but2ene. But2ene. So you have to write the geometrical isomers of but2ene. So what are geometrical isomers? You have cis isomer and trans isomer. So as you can see, C double bond C is present here. Okay, one CH3 on this side and one CH3 on this side, and H and H on the same side. So the methyl groups and hydrogen groups are present on the same side. Hence it is cis2-butene. Right, on the same side we will tell it as cis-butene. So this is a cis isomer. Now trans isomer, as you can see, one methyl on this side, another methyl on the other side, and hydrogen on this side, hydrogen on other side. So this is trans 2-butene. Okay, so these are the question, that is from 21 to 20. 9, you have the part B, out of which you have to only attend 5 questions, okay, which will each carry 2 marks, which will give you a total of 10 marks from part B, okay. So the rest, that is part C, part D, we will be discussing in the next session. So I hope what we have covered, that is the questions that we have covered in this session, is clear for you. So in the next class, let's meet with the upcoming parts, okay. So that's all for today. Thank you.